Before you can understand medieval paper, you have to understand what it replaced. For centuries in Europe, the main surface for writing important things was animal skin. We call it parchment or vellum. Making it was a slow and expensive business. You needed a calf, a goat, or a sheep. The animal was killed, and its skin was removed. Then the real work began. The skin was soaked in a lime solution for days to loosen the hair and fat. Workers would then scrape it all off with a curved knife. After that, the skin was stretched tight on a wooden frame to dry. As it dried, it was scraped again and again with a special rounded blade to make it thinner and smoother. The whole process took weeks. The final product was durable, beautiful, and incredibly expensive. A single large book, like a Bible, might require the skins of over 100 animals. This meant that books were rare luxury items. Only monasteries, universities, and the very rich could afford them. Knowledge was locked away in these heavy, precious volumes. There was another ancient writing material, papyrus. It was made from a reed that grew along the Nile River in Egypt. The reeds were sliced into thin strips, laid in a crisscross pattern, pressed together, and dried. Papyrus was much cheaper than parchment. The Romans used it for all sorts of documents. But it had a problem. It was brittle and didn't last well in the damp climates of Europe. Once the Roman Empire fell and trade routes were disrupted, papyrus became hard to get. So Europe relied on expensive animal skin. Meanwhile, on the other side of the world, a different solution had been found. Paper was invented in China around the 2nd century. The basic idea was simple but brilliant. Instead of slicing up a plant or scraping an animal skin, you could break down plant fibers into a mush, mix them with water, and then form them into a thin sheet. Early Chinese papermakers used things like mulberry bark, hemp, and old fishing nets. This new material was lightweight, cheap, and easy to produce in large quantities. For nearly 1,000 years, papermaking was a closely guarded Chinese secret. The secret finally began to leak out. It traveled along the Silk Road, the great network of trade routes that connected east and west. By the 8th century, papermaking had reached the city of Samarkand in modern-day Uzbekistan. The story goes that Chinese papermakers were captured in a battle and forced to share their knowledge. Whether that's true or not, Samarkand became a major papermaking center in the Islamic world. From there, the technology spread westward through the great cities of Baghdad, Damascus, and Cairo. Islamic scholars embraced paper. It fueled a golden age of science, mathematics, and literature. They made huge libraries filled with paper books while European monks were still scraping away at sheepskins. Paper finally arrived in Europe through 2 main doors, Spain and Italy. In the 11th and 12th centuries, much of Spain was under the rule of the Moors, who brought the technology with them. The first paper mill in Europe was established in Zativa, Spain, sometime around the year 1056. But it was in Italy that papermaking truly took hold and evolved. Italian merchants trading in the Middle East and North Africa saw the value of paper. They brought the craft back to their home country. The town of Fabriano in central Italy became the most important papermaking center in medieval Europe. The Italians weren't content to just copy the methods they learned. They made critical innovations that improved the quality of paper and the efficiency of making it. They figured out how to use water power to run their mills, a huge leap forward. They invented a way to mark their paper with watermarks, a sort of early trademark. And they developed a new method for sizing paper that made it better for writing with a quill pen. At first, many Europeans were suspicious of this new material. It felt flimsy compared to sturdy parchment. Some documents written on paper were not considered legally valid. People called it cloth parchment, and it was seen as a cheap substitute. But its advantages were impossible to ignore. It was so much cheaper and faster to make. As universities grew and trade expanded, the demand for a writing material that ordinary people could afford grew with it. The stage was set for paper to slowly but surely conquer the continent. It wasn't a sudden revolution, but a gradual shift. It was a shift that would depend entirely on a steady supply of a very humble material old rags. Medieval European paper was not made from wood. That technology was centuries away. It was made from old clothes. Specifically, it was made from linen and hemp rags. Later, cotton was also used. These plant-based fabrics were perfect for the job because they were rich in cellulose, the fibrous stuff that gives plants their structure. To make paper, you just had to break down these old textiles into their individual fibers. This created a whole new industry. An entire economy grew up around the collection and trade of old, worn-out bits of cloth. think about what that meant. A peasant's old linen shirt, a sailor's discarded hemp rope, a rich lady's worn-out undergarments, things that were once just trash suddenly became a valuable raw material. The paper mill had an insatiable appetite for them. The people who collected this material were known as rag pickers or rag and bone men. They were a common sight in medieval towns and villages. They would walk the streets with a sack and a stick, poking through garbage heaps and going from door to door, buying or bartering for any old cloth people had. It was a dirty, low-status job, but it was an essential one. Without the rag pickers, the paper mills would have no raw material. Once collected, the rags were brought to a central depot, often at the paper mill itself. Here, they had to be sorted. This was typically work done by women and children. They would sit in large rooms, surrounded by piles of smelly, dirty cloth. Their job was to sort the rags by quality and color. The best paper was made from clean white linen rags. These were the most expensive. The lower grade rags, like old canvas or ropes, would be used to make rougher, darker paper for wrapping or other everyday uses. Any buttons, hooks, or thick seams had to be cut off. The sorted rags were then cut into small, palm-sized squares. The demand for rags was huge, and it kept growing. A single paper mill could consume tons of rags in a year. Soon, local supplies were not enough. A long-distance trade in rags developed across Europe. Merchants would buy up rags in one region and ship them by cart or by boat to areas with large paper mills. Some Italian cities became major hubs in the international rag trade. As paper became more important, governments started to realize that rags were a strategic resource. Some towns passed laws giving a specific person or mill a monopoly on rag collection within the city walls. This ensured a steady supply for the local papermaker. As competition between regions grew fierce, some rulers even forbade the export of rags from their lands. They wanted to keep the precious material for their own paper industry. These laws, called rag embargoes, show just how vital this humble commodity had become. The reliance on rags had a direct impact on the cost and availability of paper. If there was a war, trade routes might be cut off, disrupting the rag supply and causing the price of paper to spike. If there was a plague, there might be a grim surplus of clothing from the dead, leading to a temporary drop in rag prices. The entire system was dependent on the cast-off clothing of society. This system worked for a few centuries, but it had a built-in limit. There are only so many old clothes to go around. As the demand for paper exploded, especially after the invention of the printing press in the 15th century, the rag famine became a serious problem. There simply weren't enough rags in Europe to feed all the paper mills. Papermakers became desperate, experimenting with other materials like straw or grass, but nothing worked as well as linen and cotton. The search for a new, more abundant source of fiber would continue for hundreds of years. But throughout the medieval period, the sound of the rag picker's cart and the sight of women sorting through mountains of old clothes were the essential first steps in the creation of a sheet of paper. Once the rags were collected, sorted, and cut into small pieces, the real transformation began. The goal was to break them down completely, to turn solid cloth into a watery mush of cellulose fibers. This process happened inside the paper mill, a building that was a marvel of medieval engineering. The most important feature of a paper mill was its location. It had to be built on the bank of a fast-flowing river or stream. Water was everything. It was used to clean the rags, to turn them into pulp, and most importantly, to power the mill's machinery. The water also had to be clean. Any impurities, like dirt or minerals, could stain the final paper and ruin its quality. The first step in breaking down the rags was called retting. This was basically a controlled rotting process. The cut rags were stuffed into stone vats or pits, soaked with water, and left to ferment for days or even weeks. Bacteria would begin to break down the non-cellulose materials in the cloth, softening everything up and making the next stage much easier. This was a smelly, unpleasant process. The retting rooms of a paper mill would have been damp, dark, and filled with the sour smell of decay. After retting, the softened, foul-smelling rags were taken to the heart of the mill, the stamping hammers. This was the great European innovation in papermaking. Earlier methods used in the Islamic world involved soaking and beating the rags by hand or with animal power, which was slow and laborious. The Italians, drawing on existing technology used for things like fulling cloth or crushing ore, developed a water-powered stamping mill. Imagine a large water wheel on the outside of the mill, turned by the constant flow of the river. Inside the mill, this wheel turned a huge wooden axle, like a giant camshaft. Sticking out from this axle were a series of cams, or lobes. As the axle turned, these cams would lift, and then release massive wooden hammers. These hammers, often tipped with iron studs or nails, would then fall with great force into stone or wooden troughs below. The sound inside a stamping room must have been deafening out, a relentless rhythmic pounding of wood on wet rags. Thump, 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 all day, all night. The rags were put into these troughs along with a steady stream of clean water which washed away dirt and impurities. The pounding was done in stages. The first set of hammers might have coarse, sharp studs to tear the rags apart. The rags would then be moved to a second trough, where the hammers had finer studs to further break down the fibers. Finally, they would go to a third set of hammers that were smooth wood. This last stage beat the fibers into a smooth, creamy pulp without cutting them. This process could take a long time, sometimes up to 36 hours of continuous pounding, to produce one batch of pulp. The skill of the papermaker was in knowing exactly when the pulp was ready. They would check its consistency by hand. If it was beaten too little, the paper would be lumpy and weak. If it was beaten too much, the fibers would be too short and the paper would be brittle. When the pounding was finished, the result was a thick, soupy mixture of cellulose fibers and water. This was called the stuff. The stuff was transferred from the stamping troughs into a large vat, usually made of wood or stone, called the stuff chest. Here it was mixed with more clean water until it reached the perfect consistency for forming sheets. The vat was often heated gently from below by a small furnace. This kept the pulp warm, which made it easier for the papermaker to work with and helped the water drain more evenly from the finished sheets. From a pile of dirty, rotting rags, the mill had created something new. It had used the power of water and the force of machinery to reduce cloth to its essential fibrous components. This vat of warm, milky white pulp was the raw potential for hundreds of sheets of paper. The next stage would be to transform this liquid mush into a solid sheet, a task that required not brute force, but human skill and delicate precision. The stamping room was a place of noise and mechanical power. The next room in the paper mill, the vat room, was a place of quiet concentration and human skill. Here, a team of 3 craftsmen worked together in a fluid, practiced rhythm to turn the liquid pulp into individual sheets of paper. This team consisted of the vatman, the coucher, and the layman. The central piece of equipment was the vat itself, a large wooden tub filled with the warm, watery pulp or stuff. The vatman stood at the edge of this tub, ready to begin his work. His main tool was the mold. A paper mold was a simple but ingenious device. It was a rectangular wooden frame, something like an empty picture frame. Stretched across this frame was a screen. In early Asian and Islamic papermaking, this screen was often made of thin strips of bamboo or reed laced together with silk or horsehair. The European papermakers developed a more durable screen made of fine metal wires. These wires were woven in a specific pattern. A series of thin parallel wires called laid wires ran the length of the mold. These were held in place by thicker wires called chain wires that ran perpendicular to them, spaced about an inch apart. When you hold a sheet of old, handmade paper up to the light, you can still see the faint grid pattern of these wires. It's the ghost of the mold that made it. Along with the mold, the vatman used a decal. The decal was another wooden frame, the same size as the mold, but with no screen. It was placed on top of the mold to form a shallow tray. The thickness of the decal determined the thickness of the paper, and its inner edges formed the paper's characteristic feathery, uneven decal edge. Another key Italian innovation was often part of the mold, the watermark. This was a small design, perhaps the maker's initials, a crest, or a symbol like a crown or an animal, that was formed from a piece of bent wire and sewn directly onto the mold screen. Where the watermark wire sat, the pulp would be slightly thinner. This created a translucent image in the finished sheet of paper, a permanent, built-in trademark that advertised the mill's quality and helped prevent counterfeiting. The process began with the vatman. He would hold the mold with a decal on top, one hand on each side. He would dip the whole thing into the vat, scooping up a layer of the soupy pulp. Then he would lift it out, perfectly level. For a moment, the mold would hold a shimmering milky puddle. This is where the real skill came in. The vatman had to give the mold a very specific, subtle, shake a little shimmy side to side, then a little tip forward and back. This motion, known as the papermaker's shake, was crucial. It caused the tiny cellulose fibers suspended in the water to interlock and weave together in a random matted layer on the surface of the screen as the water drained through. A good vatman could produce sheets of incredibly uniform thickness just by the feel of this motion. As soon as the sheet was formed and most of the water had drained away, the vatman would remove the decal and pass the mold to the second man, the coucher. The coucher's job was to transfer the delicate, wet sheet of newly formed paper from the mold screen onto a waiting piece of damp wool felt. This was a critical and difficult step. He would take the mold, align it with the felt, and then, in one smooth, rolling motion, press the mold face down and lift it away, leaving the sheet of paper behind on the felt. The word kusher comes from the French word meaning to lay down. While the coucher was doing this, the vat man had already put the decal on a second, identical mold and was dipping it into the vat to form the next sheet. The two men worked in a seamless partnership. The coucher would lay a new piece of felt on top of the sheet he had just couched. Then he would be ready to take the next mold from the vat man. They repeated this process over and over, building up a stack of alternating wet paper and wool felt. This stack was called a post. A post might contain 144 sheets of paper, a measurement that came to be known as a quires. The third man on the team, the layman, was responsible for preparing the stacks of felt and for taking the finished post to the next stage of the process. The work was physically demanding, done in a warm, humid room, and required immense skill and coordination. A good team could produce several thousand sheets of paper in a single day, a rate of production that would have been unimaginable in the world of parchment. But these sheets were still fragile, saturated with water, and not yet ready to be written on. Their journey was not over. The post, that heavy stack of alternating wet paper and felt, was carefully moved from the vat room to the press. The press was a massive piece of equipment, a huge screw, often made from a whole log, that was turned by a long lever. The post was placed at the bottom, and 2 or 3 men would work together to turn the lever, applying immense pressure. A huge amount of water would gush out from the stack, squeezed from the paper and the felt. This pressing compacted the fibers of the paper, making the sheets denser and stronger. After pressing, the sheets were strong enough to be handled. The next job was to carefully separate each sheet of paper from its felt blanket. The damp sheets were carried in stacks, known as spurs, up to the drying loft. This was usually on the top floor of the mill, a large, airy room with rows of ropes or wooden poles stretched across it. The loft had louvered shutters on the walls instead of windows, which could be opened or closed to control the flow of air. Workers, often women, would take the damp sheets one by one and hang them over the ropes to dry. They were hung in small groups of 4 or 5 sheets at a time. This was a slow process that relied entirely on the weather. On a warm, breezy day, the paper might dry quickly. In damp or cold weather, it could take a week or more. The air had to be clean, as any dust or soot could stain the paper. Once the paper was completely dry, it was still not ready for writing. If you tried to write on it with a quill pen and iron gall ink, the ink would bleed and feather, sinking into the paper like water into a paper towel. The paper was too absorbent. It needed to be sized. Sizing is the process of adding a substance to the paper to make it partially water-resistant. This was another of the great Italian contributions to papermaking. They developed a method of sizing paper using gelatin made from animals. The process was smelly and unpleasant. The papermakers would boil down scraps of animal hides, hooves, and bones, leftovers from tanneries and butchers, to create a gluey, gelatinous substance. This animal glue was diluted with water in a large tub. The dried sheets of paper were taken down from the loft and, a handful at a time, dipped into this warm vat of gelatin. They were soaked for a moment, then pulled out and pressed again to remove the excess size. This coating of gelatin filled the pores between the paper fibers. It created a hard, non-absorbent surface that was perfect for the sharp point of a quill pen. The ink would sit right on top of the paper, drying into a crisp, clean line. After sizing, the sheets had to be taken back up to the loft and hung to dry for a second time. The sized and dried paper was almost finished, but the process of dipping and drying could leave the sheets wrinkly or with a rough surface. The final step was finishing. The sheets were stacked and sometimes hammered or pressed again to make them flat. To give the paper a smooth, almost glossy finish, a worker would polish each sheet by hand. They would rub the surface of the paper with a hard, smooth object like a polished stone, often a piece of flint or agate. This process, called burnishing, smoothed out any remaining roughness and gave the paper a surface that was a pleasure to write on. Finally, the paper was ready. The sheets were inspected for flaws, counted into quires 24 sheets and reams 20 quires, or 480 sheets, and then wrapped or baled for sale. The final product was a world away from the dirty rags that started the process. It was a crisp, strong, off-white sheet. If you held it, you would feel its slightly textured surface. It would make a distinctive rattle when shaken, and if you held it up to the light, you would see the grid of laid and chain lines from the mold, and within that grid, the faint ghostly image of the maker's watermark. Compared to parchment, this new material was thinner and less durable. It could tear more easily and was more susceptible to dampness. But its great advantage was cost. Paper was dramatically cheaper than parchment. This single fact changed everything. It meant that books no longer had to be the exclusive property of the super rich. Students could afford to buy texts, merchants could keep more detailed records, governments could create more documents. And when Johannes Gutenberg perfected his printing press with movable type in the mid-15th century, paper was there waiting for it. The printing press needed a cheap, mass-produced medium to be truly revolutionary. Without medieval paper, the press would have been a curiosity. Together, they democratized knowledge. They fueled the Renaissance, the Reformation, and the Scientific Revolution. It all started in a noisy, smelly mill on a riverbank with a pile of old clothes and a lot of hard work.